All right, so today what I want to do is go through these, make sure we did these correctly. And then I'm going to kind of do a variation of what we talked about on Tuesday. So far we've been looking at values and finding the percentiles. We're going to look at a way to go backwards. And then I'm going to show you a video today of how you can maybe apply some of this. And then finally, you're going to practice some more to get us ready for Friday, because Friday we're going to have a quiz over these type of things. Okay? So I know it's kind of quick, but Friday we'll review too and stuff. And I think we'll get enough practice. We will be in good shape. But I know it's a little confusing here at the beginning, so I want to make sure that you did things correctly on this one. So let's start with the normal curve. So if you remember this first problem I talked about, the mean of their heights of the 15-year-old boys was 65 inches. Standard deviation was 2.5, and they want us to sketch and label the normal curve. So the sketching, do the best you can with your normal curve, but definitely mark where the mean is in the middle. And they told us our mean on this one was 65. And then remember, we're going to go 3 standard deviations above and 3 standard deviations below that. And each one is going to be worth 2.5. So 7.5, 70, 2.5, and then the other direction. So as far as drawing and labeling it, that's what I'd be looking for, is that. But we also talked about throwing in the percentiles, and that's going to help us answer some of the other questions. So our percentiles, remember the mean was going to be the 50th percentile. And then based on our 68, 95, 99.7 rule, we could label these others. So we decided that this was 16 and 84. This was 2.5, 97.5. This was 0.15 and 99.85. So those were all our benchmark percentiles. Well, now that we have the setup, we can start answering the questions. The first question wants to know what percent are between 60 and 70 inches tall. This was nice because 60 was on one of my benchmarks, 70 was one of my benchmarks. So I'm going to find the difference between percentile for those two. And so on this one, we're taking 97.5% minus 2.5%. So our answer was 95%. The second one, we weren't as lucky though, because if I look for 58 inches, it's not on there. So remember, if it's not on there, now we got to go to the z-score. So I'm going to start by just finding the z-score itself. So I take the 58, subtract 65, divide it by 2.5. So can somebody tell me what their z-score was on that? Negative 2.8. And I'm going to throw an extra decimal of 0 on there, because we know when we look on the z-table, we need that second decimal. All right, so that's our next step, is we're going to look at the z-table. So I'm looking for negative 2.80 on the z-table. So I go to the negative side. I find negative 2.8. Second digit was 0, so I look at 0, and I find where those two meet up. Well, those two meet up at 0.0026. But decimal or percentage-wise, I still got to move it over 2 places. So I end up with 0.26%. Now, I always double check, see if that kind of fits into my picture that I drew originally. Well, 58 was just a little bit higher than the 57.5. And 0.26 is just a little bit higher than 0.15. So at least it seems to fit, it seems to be in the right spot. All right, same idea on 4 to start at least. 67 wasn't one of my benchmarks, so I got to find the z-score. What was that one? 0.8. And again, I'm going to throw in the extra decimal. This time we're looking at a positive z-score, so I go to the positive side of my z-table. I look for 0.8. Second decimal was 0. And so I like to see where those meet. And I get this. I get 0.7881. Or if I move it over 2 places, I get 78.81%. But you had to be a little bit careful on this one because the question was not what percent were less, but what percent were more. So right now we've found out 77 or 78% were less. I want to know what's on the other side. So this is one of those where we got to take it away from 100. So once we subtract those two, we should get 21.19. Yep. And that would be the percentage that are more. So anytime you hear more or greater or above, you know you had to subtract it from 100. So again, these are kind of the main questions that we'll have to be able to do. Like I said, we're going to do a little variation on that today, though.
Okay, right.
Yeah.
I did something goofy on number 4 and I went to like -8, but that ended up being the answer to like start with. So could we normally just go to like the negative number?
Yeah, because what you did is you thought of it this way without actually thinking of it this way. If I'm looking for the ones that were more than 67, so 67 was here. So if you were thinking of the ones, wait, 67, yeah, it was positive. So what you did was you basically figured out how far from this side we were, because you looked at the negative part of it. Is that what you're saying?
Well, like on the z table, I looked at negative 0.80 instead of positive 0.80.
Okay, so you looked at how far we were this direction. I'm trying to think whether that's always going to work.
And it came up with the answer just to start with instead of.
Right. Instead of having to subtract it from 100.
Yeah.
I got to think about that. I think that's going to work because you're going to be looking at, instead of looking at the distance this direction, you're looking at the distance that direction.
Yeah.
It should be the same if you're going positive, negative. But I hate to say it's going to work 100% of the time. So let me think about that and think if I could think of an instance where it wouldn't work. Your sure bet is to take away from 100, but
yeah,
I think it will work, but I hate to say it's going to work 100% of the time.
Are the percentiles, do they always do the
I
same?
got it.
Yeah, that's the nice thing about that.
Yes, you're right.
It seems like that. All right, so on the paper I'm handing out, I'm going to have you try just the first two. They're like what we did too. So our situation this time, they looked at some measurements of some different trees, measured their circumference, and they found out that the mean was 70, standard deviation was 8. So using that, I want you to do, again, just the first two questions. See if you can figure out what's the percentage that's between those two values, 60 and 74, and then what's the percent that are larger than 68. Okay, so just those two, and then stop there because the last three are variations of what we have to do. That's a head change. Oh, just so I added 34. Right. Right. That comes from our general rule of our normal.
You have to do both. 60 and then 70. Then you have to subtract the bigger one.
So, yes.
Like, take off the lights.
I hate those. I don't like them. Okay. Wait, say how many of these are in the Okay, yeah.
This
Well,
about 68% of value.
No, I got it.
One that burns, one that burns. That's 60% of value. But that's total.
Pretty good.
Right, 95. That's total. 95.
Oh, yeah. Whoa, whoa.
Think about it, total of 60.
Yes, but how can I have? They went to the most.
That means I have 44% side. Correct. Right. I just have 95.
That's not a number. You don't need -4. You have to be doing something wrong.
And I would just start with middle.
There you go, that's right.
Is that the answer?
Just 47.
Then I gotta go to my car, right?
Yep.
Fine.
Why are you 6.5?
It's 97.5 minus 2.5.
Why?
I was looking at the last example.
What do you just learn how to do it in class?
I have this total for side.
I said, yeah.
Maybe you're not teaching very well enough.
Minus that.
Sarah? Yeah.
Plus.
Five, nine,
Now, here's what I'm saying. 99.7.
Oh, I'm done.
That turns out to be
Good game.
49.
six, nine,
So, yes,
then I subtract one.
no,
That's right.
9.
you already subtracted the.
Now then?
Oh, I know. You did it right.
So I took that number minus that.
So, this is negative.
Yeah.
You don't have positive.
So these markers here.
It's okay.
Always the same, no matter what problem we have.
One, two, three, four, five. This one is 44, 13.
Now, say I do the
Okay,
same
but
problem, what percent are
So,
less than
you do this, and you get one.
half, that was this one.
And then you subtract them.
Value. I said, what's in between 60 and 70 half.
What'd you get? What'd you get this? What'd you get?
Oh.
spelled it wrong then.
C-score versus 68.
So you remember correctly, it's the, you use this table to find
So
the
it's-
percentage.
That's what
So
And then
they're on our
subtract
marks.
it.
It's a lot easier.
I'd probably just say,
A lot of times it's not on our marks.
yeah, that's it. I need to use a number.
Z-score. What you did here is not
Hey,
wrong.
that's cool.
Right. That's why I always sketch first. See if I'm lucky enough to have it out on there.
It's simple.
It's not, but I'll show something.
Simple. It is good.
Yeah.
Subtract.
So double check your two Z-scores on the first one, see if you got those. Now, that's not our answer, but those are our Z-scores. You can start with two.
Yes. Wait, so is that the answer?
No.
No, that's just the Z-scores.
Okay.
60 minus.
Yeah, I got it.
Because I went on to 79.
Yeah, always start with the value of 80. Right.
Or just don't listen.
All right, let's see where we go from here. So I'm hoping that being able to find the Z-score is something that you're comfortable with. From there, though, let's see if we can figure out the percentiles. So again, we got to go back to the Z-score or the Z-table and find negative 1.25 this time. So I go to the negative side. I go to negative 1.2 down here. I go to 0.05, which is here, and I look to see where those two meet each other. Was here. 0.10, that I just marked it out. The 5.6.
Yes.
Okay, so 10.56%.
Yes.
That's the low end. That was this one. Then we go to a half. It was positive though, so we go to the positive side. And the positive side, 0.5 was here. So 0.6915 or 69.15%. All right, what do I do with those two values now?
Subtract those.
Subtract them. We want the distance in between. 58.56.
59.
Oh,
Yeah, I got it.
oh yeah, I got one.
Right idea. All right.
6.
What's the extra thing we're going to have to do on the next one? After we find the Z-score, we check to see the percentage. Subtract from 100. So you looked at negative 0.25. Negative 0.25's percentage. 40.13. Yes. But they wanted more or larger than, so we take it from 100. And so we should end up with 59.87. All right, good.
No, just.
All right, so we got this down, or at least getting closer, I hope. Here's the adjustment. What if I ask this? That's not it. What if I ask this? if the tree circumference is ranked at the 65th percentile, then what is its circumference? So now we're thinking opposite. So far I've said, okay, here's the circumference, what's the percentile? Now they're saying, here's the percentile, what's the circumference? So here's how I'm going to attack this. Since they gave me the percentile, I'm still going to use my z-table, but I'm going to look at a different portion of the z-table. So far, what we've been doing is we've been looking at the outside here at the z-scores and trying to find the percentiles. Now what I'm going to do is try to find the percentile and see what z-score I get from that percentile. So they said it was at the 65th percentile, which means I want to try to figure out where in here do I get as close as I can get to 0.65, because that would be the 65th percentile. Now, I'm hardly ever going to be exactly at that number, but I'm going to get as close as I can. So let's see if we can figure out where that's going to be. Well, as I kind of go through here, I've got 6.80, I've got 0.6517. So it looks like this is the one that's closest to 65%. Well, now I got to see, well, what's the z-score for that? Well, the first decimal place is 0.3. The second decimal place is 9. So I'm looking at a z-score that is 0.39. Well, how's that help me? Well, I know how to find the z-score. I know to find the z-score, I'm going to take whatever my score is, minus the 70, and divide it by 8. Right now, I want that to equal 0.39. The question is, what's the circumference? So we did some of these the other day where we're missing that piece. Do you remember what we did to find that piece? Multiply by 8, and then what? Add 70, right. So I'm going to multiply by 8 to get rid of this. So now I have x minus 70 equals 3.12. And then I'm going to add the 70. And so my circumference turns out to be 73.2. So backtracking a little bit, we found where the percentile was on the z-table. That told me the z-score. And then I set up an equation to help me figure out the missing value. Okay, let's see if we can do this next one. Well, the next one wants to know, well, how big would the tree have to be to end up in the top 15%? Now, top 15%. If I'm in the top 15%, what percent of the values are below me? So I'm in this top 15, what percentage would be below me?
85.
85, the rest of them, right? So what that means is I'm not looking for this in my z-table, I'm actually looking for this, because percentiles are the values below, or the percentage of values below. So I'm going to look in my z-table to see how close I can get to 0.85. Well, would 0.85 be above or below the average? If I'm in the top 15%, am I above or below average? I'm over here. Above average, right? So I should be looking at the positive side, the positive z-scores. But again, I'm looking for as close as I can get to 0.85. So I'm looking in here to see what that value might be. So we got 0.84. It's like here maybe, 0.8508. So I'm looking at 1.04 for z-score. So I'm going to set up the exact same equation, except now I'm going to set it equal to 1.04. So I'm still doing x minus 70 over 8. So that information hasn't changed. It's just now I want to keep the 1.04. So when I multiply by 8, I get 8.32. And at 70, I got 70. So again, if we're given the percentage or the percentile, we're thinking backwards. Then the last one's even a little bit different from what we just did. Because on the last one, they said the middle 40%. So we're taking out this middle 40%. I want to know, okay, well, what's here and what's here then? Well, first of all, if I take out this middle 40%, what percent am I left with?
60.
60. But I've got two sections that would add up to 60. So that means I've got 30% on the high end. I've got 30% on the low end. Well, if I'm thinking about the lowest 30%, that means this should be the 30th percentile here. What about the highest 30%? Well, what percent is below that mark? Even more. 70, the whole thing, right? The 40 and the 30. So I'm looking at the 70th percentile there. So I really have two things I've got to find. I've got to find where's this located, and then I've got to find where's that located. So let's start with the 30th percentile. So I'm going to look on my z-table. Now the 30th percentile would be below average. So I'm going to have to look on that negative side. And again, I may not get exact, but I'm going to get as close as I can to that 0.30. So, 8. Looks like maybe this one, 0.3, or actually, yeah, 0.3015. So that is at negative 0.52. So we're looking at a z-score of negative 0.52 for that one. We'll use that here in a second. While we're there, let's go ahead and figure out the 70th percentile. That's going to be on the positive side. And if we look here, I've got 0.6985, I've got 0.7019. So technically, even if we haven't got to 0.7, this is closer. Notice what its z-score is. Positive 0.52. Which makes sense because we went the same amount each direction there. It's just one was on the high end, one was on the low end. So I've got two problems to work out. I've got one where the z-score is negative 0.52. So when x minus 70 over 8 is equal to negative 0.52. And I've got a second problem to work out. When it's equal to positive 0.52. So why don't you go ahead and work those two out, see what your two values are. what was your value on the low end? 65.84. And on the high end? 74.16. Okay, and that would be our answer. Double check when you multiply. Make sure you did 8 times 0.52.
Yeah.
So again, those are examples. Most of the examples we'll do will be the ones where here's the value, find the percentage. Sometimes though we have to go in reverse. Well, like I said, I want to show you a